Hello everyone and welcome to the channel. I'm Emmanuel, I'm a former Boeing 737 pilot, and welcome to the next tutorial for the iFly Boeing 737 MAX. In the last one we have set up our FMC, so on this one we're going to set up the rest of the cockpit. So let's dive right into it. The cockpit scan flow is divided in a certain logic, which we're going to follow for our setup. Personally, since there are a lot of switches involved in the 737 MAX, I do find it a lot easier to remember everything when you are following a certain logic. Now, the 737 is built to follow a certain logic as well, and that is basically going from the top to the bottom on each one of those vertical lines that you have on the overhead panel here. So, number 1 over here, number 2 over here, number 3 over here, number 4 over here, number 5 over here. Once you're done with that, you go right to left on the light panel, and then we go back down and go over the MCP. Once we're done with that, we're going to do the same on the aircraft's main panel, going over here, going down here, onto the panel in between the FMCs, and last but not least, we are also going to go over the pedestal, again top to bottom, left to right. That way, you have an organized scan flow, and it is much easier to remember everything that you have to do. So let's go ahead and start on the overhead panel on the top left. On the flight control panel, we make sure that all the switches are guarded. We make sure that the yaw damper switch is on and that there are no lights illuminated. Moving further down to the navigation transfer and display switch panel, we ensure that all the switches are in the normal position and that the source selector is on auto. Moving further down to the fuel panel, we ensure that the engine valve closed and spar valve closed lights are illuminated on both sides. And then we move further down to the crossfeed panel, or to the crossfeed selector. We open that one, ensure the valve goes bright then dim, and then we close it again and ensure that the valve goes bright then dim. This indicates correct operation of the valve. Moving further down, we are going to switch all fuel pumps on for tanks that contain fuel that we want to use for our takeoff. Note that the center tank fuel is not used if you have 453 kilos or 1000 pounds or less fuel in the center tank. Since that will be the case on today's departure, we are going to leave the center tank fuel pumps off. Moving next up then, we get to the electrical panel, and over here we ensure that the battery is on and guarded, and the cabin utility and iFly galley power switches are on. You can set your DC and AC meters to a setting, but there is no requirement to use these on any. Now, most pilots are probably going to use the APU generator or one of the engine generators, and will set the selector to the TR number 1, as that provides you with usually the most useful sort of indication. Moving further down on the panel, we ensure that the standby power selector is guarded and the IDG disconnect switches are guarded, and the bus transfer switch is guarded. The generators are selected as needed. In general, we want to use the ground power as much as possible, since using the APU generator would create additional fuel usage, while the ground power unit has been paid for anyway. Further down, we ensure that the wiper selector is in the park position. Going down to the middle panel then, we set the lights as needed, ensure that the equipment cooling switches are both on the up position, so the norm position, the emergency exit lights are guarded, and the fastened seatbelts can be turned on as soon as the refueling is completed. Today let's assume the fueling is complete already, and let's turn this on. We keep the no smoking switch in the off position. The no smoking switch indicates to us that the cabin is not secured yet. So, just as a small background explanation, the no smoking sign is always on in the cabin. The switch does not have any actual effect. But the switch has 3 positions, and we are using them as a reminder. So with the switch in the off position, we assume that our cabin is not ready, so the passengers are still standing up. Once the passengers are all seated and we are ready for pushback, we're going to switch this into the auto position, which serves as a reminder that the passengers are sitting, but the cabin is not yet secured, so the flight attendants are still standing, for example, to commence the safety demonstration. Once the cabin is completely ready for takeoff, we're gonna switch it into the on position, and that is our indication that the cabin is now secured for takeoff. Since we are still during the boarding over here, we are going to keep the switch in the off position. Moving further down, the wiper selector is in park. Next up, we end up on the fourth panel. Over here we turn the window heat switches to on, ensure the probe heat is in the off or the auto position, the anti-ice is turned off, and the hydraulic pumps are turned on. We do not need to do any flight recorder tests here, and on the cabin pressurization panel, we ensure that the differential pressure is 0 since we are on the ground with the doors open. Anything else would indicate a malfunctioning indicator system. Likewise, the same applies to the cabin vertical speed. Moving further up then, we've got our air conditioning panel, and over here we ensure that the position of the air temperature selector is either on the forward or on the aft passenger cabin. Moving down from there, the trim air has to be on, and the cabin temperature selectors ideally are set to A for the cont cabin, U for the forward cabin, and T for the aft cabin. Unfortunately, iFly in the beta version that I'm using only models this in larger steps, so we can't really set them that accurately. Moving further down, the recirculation fans are on/auto. The packs are in the auto position, isolation valve open, no lights illuminated, and the engine bleeds are on. The APU bleed is as needed. If the APU is already running and can provide air conditioning, turn it on, otherwise just keep it off. In general, if the weather conditions outside are adequate and there is no need to heat the cabin through the APU bleed, leave the system off, as it does increase the APU's fuel usage quite significantly. Going further down on the pressurization panel, we set the flight alt to the initial planned cruising altitude, so 36,000 feet in today's case, and the landing altitude to our landing field elevation. Now there is two different possible sources that you can use for these. Either you can have a look into the flight plan. For example, the flight plan format we're using over here is the Ryanair format, and on page number 3 you can find your destination field elevation. However, since not all flight plan formats have that, here is a small trick on how you can get hold of that information, and that is through the flight management computer. If you go to the legs page and then find the destination runway waypoint, so over here, runway 28 right, then you will find that this also shows you the field elevation, but normally it would have 50 feet added to this. Remember, on a normal approach, you cross the landing runway threshold in 50 feet. Unfortunately, this doesn't seem to be simulated by iFly just yet, but I will make a bug report about that, and in the future, hopefully you should see this, plus 50 feet. In other words, you take the value that you have over here and you subtract 50, and then you know what your landing altitude is. Last but not least, we verify that the pressurization mode selector is in the auto position and the outflow valve shows fully open. From there on, we can go down to the lights panel, and we make sure that the wheel well light is on, even during the daylight, since the wheel wells are rather dark places, since they are very well shielded. So not a lot of light goes into them, therefore we turn those on the ground. The wing lights are off, anti-collision light off, position light in the steady forward position, and logo light off if it is night. We make sure that the engine start switches are in the off position and the ignition is selected according to the following principle. If you're operating through a manned engineering base, or if it's the first flight of the day, you're going to select the right igniter. The reason is the right igniter runs off the electrical standby system, and therefore the engine start later on is a good test for the standby electrical system. If you are operating on an unmanned station, so where there is no maintenance available, then you would use the left ignition switch. both is basically not used on the ground. So today we do have maintenance available, so we are going to use the ignition on the right hand side. Use the APU as needed. In general, leave it off if it is not required for electrical power or for providing air conditioning to the cabin. The landing light switches, the runway turnoff and the taxi light are all going to remain off for now. From here on we can move further down and we get to the Efis control panels and the mode control panel. So on the Efis control panel we ensure that the baro selector is set accordingly. In areas where inches are used we select inches, and where hectopascals are used we select hectopascals. Next up we are going to set the current QNH, and during today's weather conditions we have a QNH of 3000. So let's go ahead, inches are selected, and then we can select 3000 on the altimeter up here. The meter switch is used at your convenience, but basically unless you're flying in China, meters are not really used. Use the vertical situation display as necessary. Some pilots do like to have it active as it provides you with some good vertical situational awareness for terrain that you might be departing over. For today's flight I am going to leave it on, since Las Vegas is in a rather hilly area, or not to call it a mountainous area. For this reason I will use the vertical situation display on this departure. The flight path vector can be used as needed. Personally I'm not a great fan of it, so I will leave it off. The minimum selector by default should be set to the baro position, and you can dial in the minimum flap retraction altitude there, which normally is 1000 feet above the field elevation. I have to admit though that since this is currently not a very intuitive system, and since it would take very long to dial something in, I will just not do it on today's video. Select the VORs or NDBs as needed. By default the VOR position is selected on both sides, and we are just going to keep that for the time being. Map should be the active mode, and normally we are using the expanded map over here and not the full 360 degree view, so normally you're using this display format here. Select the display range as needed, and note that the range is shown on the top left of the nav display over here. The idea behind this is that in the 737 MAX you can zoom into a much lower level than you can on the older 737 NG, which is useful if you've got the airport maps on your navigation display, which however at this time is not modeled by iFly. Moving to the side then, we are going to ensure that traffic is selected, and then we also ensure that of all the different options we have down here, we normally select airports and terrain. So terrain is already active here, and on the top of the nav display over here you can see that we do have airports active over here as well. Moving on to the side then, we have our mode control panel, where we are going to make a couple of selections for our departure. First of all, we are going to turn on the flight director, and be sure that you turn on the side of the pilot flying first, so that the master light is illuminated on the pilot flying side. So in our case we are flying from the captain's seat, so we turn on the captain's flight director first. Next up we are going to set the courses, and normally we would use the courses together with the VORs in order to back our standard instrument departure up as needed. Now in today's case the departure is completely based on area navigation. As you can see looking on here, there are no conventional radials or anything over here, so we can't really set that for our departure. So what we could do is to select the runway tracks so that we could set up an ILS for an immediate return. Our departure runway is 26 right, so let's take the ILS chart for runway 26 right, and we can see that our runway courses are 259. So I am going to dial 259 into the course selectors up here. Going further to the right then, the speed remains at 100 knots, the auto throttle switch is off, and on the heading switch we are going to set our runway heading. In today's case that is 259. The altitude is set to our initial climb, and the angle of bank selector down here is in the 25 degree position, which is the default position that we should be using. Going on then, on the right hand side the autopilot disengage bar is up, and we can set course number 2 to our runway track here as well, since there is nothing to back up on our standard departure. Moving on to the right, we've got the first officer's Efis control panel, which we are going to set up in the same way that we did on the captain's panel. So, moving back on to the main panel then, we can start top to bottom, and we are going to use both test positions on the selector over here. Over here we've got the light test, which we are going to activate, and then we're going to check every single light bulb that we have in the cockpit. All of those switches are equipped with 2 different light bulbs. In case one fails, the others would still show you the light as illuminated. Nonetheless, it does happen that occasionally both bulbs fail, and if that happens, we want to ensure that we know about it ahead of time so that we can't miss any warnings later on. If any bulb is broken, as figured out in the test over here, you do have spare bulbs available on the top right over here, and this is one of the only maintenance actions that a 737 pilot is permitted to perform. You can exchange light bulbs. Doing this is rather easy. You take, let's say for example, the entire low pressure switch over here, you pull it out, and then you can simply take the bulb out, put the new one in, and stick it back into the panel. Be very sure that the switch actually sticks right back in, especially on the overhead panel, and that it holds. Now, don't ask me how I know. Yes, I did crawl through the flight deck trying to find those bulbs after the thing fell down from the overhead panel. Just don't ask for details, okay? So, moving on then, we have the ISFD, Integrated Standby Flight Display, over here, where we are going to make our altimeter setting to the same setting that we did on the primary altimeters, and once this is done, we are going to compare the 2 indications, 2180 here, 2000 over here, and those have to be within 200 feet of one another so that we're allowed to fly. So moving on to the right hand side, we are going to check the indicator on the right hand side, and moving further down we make sure that the nose wheel's alternate steering switch is guarded, which leads us down to the panel down here. So, fuel flow, reset, auto brake, RTO. Make sure that the disarm light first illuminates, then extinguishes. Check that we have brake pressure. And then we are going to go up to the MFD switching over here. While we're at this, we are going to select the system display and ensure that any indication over here is normal. So the hydraulic quantity is not showing the RF indication, which would stand for refill, happens at 70%. We ensure that we have positive hydraulic pressure, and if we are equipped with the brake temperature indicator or brake pressure indicator, we would also check for those. Then we move on to the ICAS and check the oil quantity to make sure that we have sufficient oil quantity on board here as well. As we're already moving down on this panel, we can use the engine transfer button in order to show the ICAS display on the side of the pilot that's going to be pilot flying. Now, if you're flying on the captain's seat, you are going to display this panel on your side. If you're flying from the first officer's seat, you would transfer this over to the first officer. Last but not least, we go onto the info panel and make sure that both the N1 set and the speed reference buttons are selected onto auto, respectively. When you're done, close the remaining page, and then we can continue moving down on the panel. The parking brake is set, fuel control switch is cut off, stabilizer trim cutoff switches are in the up position and guarded. Moving down onto the fire detection panel, the overheat detect switches are in the normal position, and the engine and APU fire switches are pushed in. Moving down to our radio, we are going to use radio number 1 for our active ATC communication, so that means we are going to tune whatever frequency is necessary. Now, if we were flying this one in the real world, then I would do my radio setup as follows. First of all, we will need the delivery frequency, so that's 118.0, as we can see up here. So I'm going to tune 118.0 into the active frequency, and then I would pre-select the ground frequency, which today, let's see, we are to the east of runway 01 right So it's going to be 1 to 1.1. And that in the standby. On the right-hand radio, we are always going to tune the guard frequency into the active unless we need something in particular. So for example, today we would tune the guard frequency active and then the Asus frequency 132.4 onto the standby. Like that. Okay. So that would be one way to set up your radios. If you're flying on VATSIM, obviously you are going to tune whatever controller is online active, and if no controller is online, you are going to use the advisory frequency 1 to 2.8. Moving down to our multi-mode receiver, we are going to tune something sensible. So, since we decided earlier on that we want to prepare the aircraft for an immediate return, we could, for example, select the ILS frequencies of the departure runway, so 110.3 up here. So the way we do this is, first of all, we got to select the correct mode. You can see right now VOR is the active mode. We cannot enter an ILS frequency into the VOR. Much rather we use the mode button to dial up the ILS, and now we can enter the ILS 110.3 and we can switch that active, and now the ILS frequency is active. Another possibility for something to tune would be the Las Vegas VOR 116.9, and let me just tune that active over here to show you a little difference. So right now we have set both of those frequencies up, but if we have the ILS frequency active, you will see those ILS indications on your primary flight display. Personally, I find them a little bit annoying. Therefore, what I'm going to do is I will set the frequency of that Las Vegas VOR active so that our primary flight display is nice and clear, but we have the ILS frequency readily available in the bottom over here should we need it. And I'm going to do the same setup on the pilot monitoring side, so 110.3 going active and 1169 for the VOR is now active as well. Moving further down, we get to our audio control panel, and over here generally we want to transmit on VHF number 1 and we want to listen to both VHF 1 and 2. Also, we want to listen to the interphone and not to the cabin interphone. Last but not least, I like to turn the speaker up so that we can hear everything on the speaker as well. And this is how I would set up my audio control panel. Moving down to our third radio, we are going to tune the data frequency over here for our ACARs, and we do this by simply rotating down to the lowest number, so 118, and then one further down and you get the data frequency. And we're going to tune that active. The standby over here can very well be used as a reminder for your departure frequency. So we are going to do this, having a look at the departure chart, Joker 3 departure, and we can see Las Vegas departure is on 125.9. So what I'm going to do is I will dial 125.9 into here and keep it on the standby, so that when we do our lineup on the runway, once we have been transferred to the tower frequency, we can simply look down here, take that frequency and dial it up in the standby of the active radio, so that once we have tuned tower, we are ready to simply switch over to departure as soon as we get the handoff. Quite a nice shortcut that a friend from the 777 has showed me, but works very well, so I can only recommend you to do this as well. Moving down then to the middle of the pedestal, on the cargo fire panel we make sure that the detection selectors, the loop selectors, are both on norm, the discharge switch is armed, and the arm switches are not armed. Moving further down to the weather radar, we ensure that both radars are set into auto mode, and here comes a huge gotcha. The test switch is selected into norm. There are a couple of pilots, some rumors say, that would leave them on the test position when they leave the aircraft, and when you do that, when the switch is over here, apart from the rumor, by the way, it's normally the maintenance personnel that just forgets it there after running the maintenance test. Remember, as pilot, you don't have to do that test. So when the switch is over here and you activate the weather radar when lining up on the runway, you're pretty soon gonna get a wind shear warning, so be sure that that switch is in the norm position. Moving further down, the gain is set to the calibrated position, and that applies to both sides. This leads us to the transponder, and over here we are going to select the altitude source and the transponder to the side of the pilot flying. So if the captain is flying the aircraft, you will set altitude source and transponder to number 1. If the first officer is flying, you would select number 2. Since we are flying from the captain's seat, we are going to use the number 1 position. The mode selector itself goes to standby, and the squawk should set to 2000 unless you have anything else received by air traffic control. Select the TCAS above and below selector to the above position, and the mode selector itself to the alt off, that's the complete left position. There is no need to conduct the TCAS test. Set the ADF as needed, and ensure that the rudder and aileron trims are centered. In the real world, we would also have done a small test, so just put it to the right, put it to the left, ensure that this is moving. However, since I find it very hard to bring them back into the exact neutral position in Microsoft Flight Simulator, I am gonna skip that test in the sim. Be sure to check your aileron trim as well, and the aileron trim scale is located up here on the control column. So you can see it over here, the aileron trim is in the neutral position. Be sure that you actually leave it in there. Last but not least, moving over to the right hand side, we've already set the radios, so all we got to do is set the audio control panel, and over here again we select VHF 1 and 2, interphone, and the speaker. Last but not least, moving down, the stabilizer trim switch is in the guarded position and the flight deck door selector is in the auto position. Well, and this, my friends, concludes the setup of the flight deck of the Boeing 737 MAX. I sure hope that you found this one interesting. As always, be sure to leave your comments and your likes below the video. And if you really love what I'm doing on this channel, I would appreciate a small donation through the Buy Me Coffee link in the video description below. Thank you very much for watching, and I see you all again on the next one.